Hey guys, let's go to problem 29. Okay, so 29 out here. So I got some weird looking function. 1 over floor part of x equals x. All right, so 1 over floor part of x equals x. All right, so when do we get solutions? That would be a good problem, right? This would be a really, really good problem. Okay, so first off, would you notice that that's an integer part? And this got to be also some kind of like the real number. And just thinking about those case working on x's, on such that x is in between -1 and 1, or -1 and 0, and 0 and 1, and 1 and 2, you can actually solve it accordingly and try to find out those solutions as well. But I'm just going to move on. I'm just going to try to figure out the sketch of this graph. How would you sketch this graph? Well, here's what's going to happen. I really want to sketch y equals 1 over floor part of x. All right, so we're gonna approach this question using the floor part. So how do you sketch the floor part? You know, like how would you graph the floor part of those x's? And I would say the floor parts can be sketched just like a staircase function. And because they look like a staircase function, I would say, it just looks like this. And of course, there's a like -1, and there's going to be -2, and we got ... and we got ... Right. So this would be the sketch of y equals the floor part of x. The hard part begins when I have to somehow reciprocate to find out the reciprocal of all these values. But it's okay. We're going to lock it down to some of those intervals, and we're going to find out what will happen. So here's what's going to happen, right? I'm going to draw some vertical line. Those are 1 and 2, and vertical line, and ... vertical line, and vertical line, like 4, and ... 5. And of course, I get just 1, 2, and so on. Right, so here we go. If we have a function that is in between 0 and 1, what is 1 over 0? Undefined, infinity, right? It becomes infinity. So this portion is totally gone. We don't find any of those portions out there. But what happens in between 1 and 2? Now, 1 and 2, I'm going to use different color. 1 and 2, if I take a reciprocal of 1, it just stays as 1. It just stays as 1, okay? Now, what about the x value between 2 and 3? The y value is going to be 2. If you take a reciprocal of 2, it becomes 1/2. So I'm going to sketch 1/2 out there. Now, what about the reciprocal of 3? If you take a reciprocal of 3, that becomes 1/3. And that 1/3, it's going to be sketched right there. And you can also take a reciprocal of 4, and that becomes also the reciprocal in that following form. And it keeps going downward and downward and downward. And there's no portion that you need to draw in this empty page out there. In the empty column, I would say, it should be staying as empty column. We won't have any graph, okay? But what about something that stays in between -1 and 1? Well, -1 and 0, right? So -1 and 0, the y value happens to be just -1. And I would say 1 over -1 will be just -1. So we get this portion out there. What about -2? You know, like in between -1 and -2. Well, these values are -2. If you take a reciprocal of -2, it'll be sketched right there. And we continue graphing all of these. We continue graphing all of these, right? We continue graphing all of these by extending all these points, I would say. And I just need to find out the intersections between y equals x. So if I sketch y equals x, let me use y equals x like this. Just like this. All right, so let's just try to focus on the red line and the segments out there. We got one point of intersections. We got another point of intersection. And don't tell me we get an intersection point out there, because 1 over 0 is not going to exist. It's undefined number. So we get 2 points of intersections, and we happen to get a solution at x equals, let me just write it with the black pen, at x equals 1 over the floor part of x equals x, at x equals either positive 1 or negative 1. So we found two solutions. Two solutions. And that shall be it.